Hi everyone. Today we're going to be talking about the idea of linear, quadratic, and exponential functions. So go ahead and follow along with me for your notes. Linear functions have a constant rate of change. We actually already know this from a previous set of notes. The graph looks like a line. So if you're to look at a graph of a linear function, it's going to look something like that. The function is constantly adding or subtracting by the same number, meaning it's also called an arithmetic sequence. So like arithmetic is about adding and subtracting, linear functions are about adding and subtracting constantly. These equations usually look like y equals mx plus b. So if I were to give you an example, it would be something like y equals 2x plus 1. Okay? Now we're going to be talking about exponential functions. So exponential functions involve a constant raised to different powers. So we know exponents, like let's say 3 to the 4th power, that means 3 times 3 times 3 times 3. So exponents, exponential, they involve the function is constantly multiplying or dividing by the same number, meaning it is a geometric sequence. So exponential and geometric, those mean the same thing, and linear and arithmetic, those mean the same thing. So these equations, they look like something y equals a times b to the x power. So if I was going to use these same numbers, 2 and 1, to create an equation, it would not be y equals 2x plus 1, it would be y equals 2 to the x power plus 1. So notice the difference between this and this right here. Okay? And then finally, the last type of function that we're going to be talking about is a quadratic function. Quadratic functions have a rate of change that creates the graph of a parabola. That's a parabola. These equations usually have a second power, like y equals x squared. So again, I'm going to write an equation that would be quadratic but uses the number 2 and the number 1. So it would be y equals 2x squared plus 1. So notice how this is also different from this one and from this one. This one has a second power, which makes it quadratic. This one has x in the exponent, which makes it exponential. And this one is just multiplying 2 by x, making it linear. Okay, so let's dive into some examples here. So today we're going to be looking at if you had a table and a graph, how would these look differently? Okay, so to classify the type of function, determine if there is a pattern and the rate of change. You can also plot the points to help you classify the function. So let's look at example 1. All right, now really on all of these will all be adding 1. So really I'm more concerned about how my y, my function is growing. So 4 to 7 to 10 to 13 to 16. I recognize that that's a pattern of adding by 3. Now I know from the set of notes that I just took that constantly adding means the function is going to be linear. But let me just prove it to myself also by plotting the points. So negative 2, 4, that's to the left 2 spaces and up 4. Negative 1, 7, that's to the left 1 and up 7. 0, 10, that's straight up 10. 1, 13, that's to the right 1 and up 13. Now I'm off the graph, but I can draw a line. If I drew that straight, you would recognize it as a linear function. So the function is linear / arithmetic. Because it has a constant rate of change, or it's constantly adding. The function is not, let's say, exponential because it is not constantly multiplying. You're just trying to make your explanation pretty good by explaining something that it is not. Let's go ahead and move forward to the next example. Example 2. So if I'm looking at this example, again, all of these are just adding by 1, adding by 1, adding by 1. So really I'm more concerned with what's happening on the y-axis. So if I go from 0.5 to 1 to 2 to 4 to 8, I see that this is growing differently. Now when I look at this, I recognize that this is multiplying by 2 every time. 0.5 multiplied by 2 gives me 1, 1 times 2 gives me 2, 2 times 2 gives me 4, and 4 times 2 gives me 8. So this function, remember multiplying constantly, is going to be exponential. So the function is exponential or geometric because it is constantly multiplying the same number. Okay, and the function is not linear because it does not create a straight line. Now let me actually prove that to you all so you can see it. Okay, so negative 3, 0.5, that's to the left 3, and that's kind of halfway between 0 and 1. Negative 2, 1, that's to the left 2, and just up 1 space. Negative 1, 2, that's to the left 1 and up 2 spaces. 0, 4 is straight up 4. And then 1, 8 is to the right 1 and up 8. So you would recognize that this is growing rapidly, and it creates a curve of an exponential function. Okay, well, let's do that last example. Example 3. Now this is a case again where these numbers are adding by 1. So you're really more concerned with the rate of change of y. And you can determine that by a few different things. So 13 to 8, 8 to 5, 5 to 4, 4 to 5. So it's an interesting pattern here. So it might be helpful to first figure it out with the rate of changes. So 13 to 8, I'm subtracting 5. 8 to 5, I'm subtracting 3. 5 to 4, I'm subtracting 1. And then 4 to 5, I'm actually adding 1. So this is kind of an interesting pattern. I don't know right off the bat, so I'm actually going to go ahead and graph this. So negative 3, that's to the left 3, and then up 13, that would be up the graph somewhere over here. Negative 2, 8, that's to the left 2, and then up 8, that'd be somewhere right here. Negative 1, 5, left 1, up 5, that'd be somewhere right here. 0, 4, that would be straight up 4. And then finally 1, 5, that's to the right 1 and up 5 spaces. So it actually has the beginnings of what we call a parabola. Okay? A different way that you could tell this as well is from -5 to -3, that's actually adding 2. -3 to add -1, that's adding 2. And -1 and +1 is adding 2. So when the second difference is the same, it's going to be quadratic. Or you could simply say it creates the shape of a parabola. So the function is quadratic because it creates the shape of a parabola. You could say this function is not linear because it does not create a straight line. Okay, if you have any questions, please let me know. That's our video for today.